And I'm in Florida this week, just a little vacating, but we are going to go down to Kennedy on Friday to see Artemis, to take a look at the ship, although we will be seeing it from about 5 miles away. I'll take the binoculars to make sure I can see it. But tonight's discussion is a question I get almost every time I present. What does it take and what is necessary to become a NASA astronaut, and how is the selection process? So with such an interesting question, I decided we need to make a presentation just for that, go through the process and whatnot. As my introductory slide, for people who don't know me, I was a chief system engineer from Kodak and L3 Harris, and they would contract me out to NASA a couple times. I spent 6 years there at JPL, the last 3 years. So that's on the West Coast, out of Pasadena. And when I left L3 Harris, I stayed with the program, the NASA program. So I'm a solar system ambassador. So what you're looking at here is the Earth, obviously, from 23,000 miles away. And one of the satellites that I built with them was the lead telescope designer and fabricator on this. And it's called GOES-R. And it's imaging the Earth every 30 seconds. And it is what you see on the Weather Channel. When you turn on the weather and look at the radar, that's what you see. It's a rectified image of this image from geosynchronous orbit. This particular image was in 2020, and we caught a solar eclipse sweeping by South America. And so I love to show that image. Okay, so right now Artemis 2 is on the pad. There's a picture of the spacecraft with its launch vehicle. We're hopefully waiting for launch, maybe April 1st would be great. It'll be during prime time, so that first launch window is 6:34 p.m., right during the national news. You can watch it. I'm sure they'll stream it and they'll show it live on the networks, or you can join a watch party. So that little picture on the right, that's from one of the watch parties. NASA sponsors launch parties at all the facilities, so you could stream the launch from a watch party and enjoy the camaraderie of other space nerds. And that's probably what we'll do. But tonight we're going to talk about what does NASA require and what are the qualifications and the process of becoming an astronaut.
My name is Johnny Kim. I'm from Los Angeles, California, and I'm a Navy SEAL and physician.
Before NASA, I was a research engineer at Woods Hole Oceanographic Institution. I was actually a PhD student.
I was on the faculty at MIT in aerospace engineering.
3 years ago, I was serving at the Naval Academy. Now I'm here at NASA becoming an astronaut.
The training process for me is incredible because no day is the same.
We've been learning to fly T-38s. We've been learning to fly the robotic arm. We've been learning space station systems.
You're constantly changing your focus, but you always have that one part of training that just doesn't, your brain isn't wired for. And for me, that's learning Russian.
I think for me, one of the most memorable moments was my very first run in the neutral buoyancy lab.
I've watched spacewalks before. They make it look so easy, and it's an entirely different spacecraft, and learning to work within that and fighting against the pressure.
The first time that I got into the spacesuit and I slipped my hands into the gloves and I looked down and realized that this was actually happening, but I could actually go to space.
One of my favorite weeks of ASCAN training overall was 1 week we were out in the wilderness for 10 days together.
We were all cold. We were all miserable.
It's in those moments that you really learn to give others grace. Working in teams in remote places was one of the best things to prepare me for this job.
Every obstacle that we were able to complete together made us stronger. We've all been working really hard, and we finally get to realize our childhood dreams of finally becoming astronauts.
This is my first and my time calling. We are so inspired.
Without further ado, let's welcome the world's newest astronauts to the stage.
The turtles have earned my absolute trust, and it would be nothing short of an honor to fly with absolutely any single one of them.
And we get to receive our coveted astronaut pin.
This pin represents all that we've prepared for.
The pin means that really we are full-fledged astronauts and ready to one day fly in space.
Whatever missions we may find coming our way in the future, we'll be ready for them.
I would love to go to space with Jenny because she has this infectious curiosity about the world around her.
Frank is truly a wonderful person, and he's going to make an awesome astronaut.
I would love to explore space with Raja because you can always count on him.
Ladies and gentlemen, your newest astronaut, Laurel Harrell.
Human spaceflight is difficult, and it takes all kinds of people with all kinds of strengths and all kinds of skills to all come together with one passion to accomplish these things that are really difficult.
The adventures ahead of us are going to be like nothing we've seen before. This team is capable of anything, especially when we're together.
Think you have what it takes to be an astronaut? We are now accepting applications. Learn more at nasa.gov/astronauts.
So, of course, that was the video from the 2020 class. They were inducted in 2020. And here is the 2025 class. So that was the class that was recruited from that video. And so this class was just inducted last October. And for the first time, you'll notice there's more ladies than men in this class. So it was very interesting to see the way things have gone down through the years, recruiting all of our NASA astronauts. So tonight we'll talk about how to become an astronaut. We'll talk about 4 items. What degree should you pursue? So getting a degree. What is the training that's involved? The 2 years of ASCAM training down in Houston, Texas. We'll go over that quite quickly, but we'll talk about staying healthy and what it takes to pass a NASA astronaut physical. As you can imagine, that's pretty different than the physical we get each year at our doctor's office. And then we'll go over what I call the secret sauce. How do you get selected to go to space? And that is something that very few people know of, and we'll discuss how they do that and who's making these decisions and when. And so hopefully we'll enlighten you on some of that stuff. So there's our learning objectives. This is one of our astronauts in training here on the right. That's actually our granddaughter. She's only 12 months or 14 months old, but she already has her spacesuit. So she's getting ready to go. Let's start with a bit of history. As you know, the astronaut program started many, many years ago. Not quite this many years ago, though. The word astronaut means star sailor in Greek and has appeared in cave drawings and Renaissance paintings for years and years. People have thought of going to space for many, many years, but it wasn't until 1958 that we had the first person to actually go to space. You might ask, well, who was that person? And there's a lot of discrepancies about that. The Russians would say, it was Gagarin, but the Air Force would say, no, it was Joseph Walker, who flew an X-15 in 1961 to space. And the first person the Air Force sent was Robert White. So there's a bit of discrepancy. And we were running in the 58, this program with a rocket plane, we call the X-15, which would accelerate to enough velocity, 6,000 or 7,000 miles an hour, to escape the Earth's atmosphere, but not the Earth's gravity. So it was an up and back down. And even Neil Armstrong was one of these pilots. So, in fact, he was the only one that would transition to the astronaut program from this program. But this is where we started in 1958 with the U.S. Air Force program. And it was then transitioned to NASA in the 60s. So that's why the plane does have NASA on it.
On April 9th, 1959, NASA introduced to the world the original Mercury 7 astronauts: Gus Grissom, Scott Carpenter, Deke Slayton, Gordon Cooper, Alan Shepard, Wally Schirra, and John Glenn were chosen from a pool of over 500 military test pilots to become the first group of astronauts to lead America into space under Project Mercury. NASA celebrates the 50th anniversary of the Mercury 7 astronauts.
Well, these, of course, were my heroes when I was a kid in grade school. The original celebrities of science. That's what we looked at these men as. And this was very, very early in the program in 1959. And these guys had just some basic qualifications. So they had to be under the age of 40. They had to be short, less than 5'10", 5'10" and under. They already had to be military test pilots with 1,500 hours of flying high-performance jets and have a bachelor's degree in science. But that reason they had to be military was because they still considered this a classified program at that time. They were flying on U.S. Air Force classified missile technology, for their boosters. So to be aware of all of that, they wanted these first 7 guys to have a security clearance. You notice they end up piloting and flying on a lot of missions, these original 7 guys, and 4 of them even walked on the moon. And believe it or not, John Glenn actually flew in 1995 at age 77. So, don't think you're too old to have done this. I was kind of amazed. Of course, it did help that he was a senator and, responsible for the funding. But that's the original qualifications for Mercury, those first guys. The second set of guys coming along 3 years later, they call them the New 9. Every class has its own little nickname. So that it was the original 7, the New 9. And here you're going to start to see some of the really familiar names. Of course, Neil Armstrong comes over in this group. John Young comes over in this group, who's by far and away the best pilot we've ever had at NASA. A lot of reasons why that is. And then Jim Lovell from Apollo 13 fame. Ed White, first man to walk in space, who passed away in Apollo 1, and on and on. Frank Borman was Apollo 8. He did that famous Christmas from the Moon transmission, you might remember. Now, that second class had 250 applicants, and only 9 are selected. So this is an incredibly selective group. And it even gets worse than that as we proceed forward. By then, they have a selection board. So now we have a Mercury astronaut, Deke Slayton. He's in charge of this board. And of course, when you're with the government, you have to have a flow chart. So here's the flow chart. You get your applicants in and you scroll through immediately and find who's not qualified. They drop out at the bottom. And then you find out who's highly qualified. And that eliminates about 75% right there. Then you have two rounds of interviews to get them down to a specific number they're looking for. In this case, it was in 2009, and they were looking for 8. And they selected 8 out of 3,400 applicants. So gives you an idea of just, how selective. Now, at that point, still looking for a bachelor's degree, but they wanted years of a related professional experience. So not just fresh out of college, they wanted someone with some experience. And of course, you had to be able to pass the astronaut physical. So by 63, the third class pretty much rounded out the Apollo program. And there were 14 in that class. And again, Michael Collins, who was on Apollo 11, Buzz Aldrin on Apollo 11, and so forth. Lots of other names you would recognize. But now the size is up to 6 feet. That kind of opens the door to a lot more applicants because the capsule's a lot bigger. I did have a picture of myself in that Mercury capsule, and I did not fit in the capsule. Maybe that picture will come up. I've forgotten. You did need a degree in science and engineering. All of these guys in the picture there, most of them have master's degrees. They waived the test pilot, but they still wanted pilots. So you needed the 1,000 hours of being a pilot. But the age was lowered because they realized they wanted these astronauts to be around for a while. So they wanted to lower the age so that there would be availability for 15, even maybe 20 years you could make a career out of being an astronaut. So, and yes, these guys hung around right on through the shuttle era, and were many of the pilots and commanders of shuttle missions down through the 70s, even into the 80s. So many of these guys were there for 20 years. Now, the fourth class was much different because by now they'd rounded out all of the Apollo program and they were into Skylab. So Skylab followed Apollo and they needed scientists. So this fourth class, it was the scientists. They had 1,300 applications and they chose five. But of the applicants now, they had to have a PhD. So they wanted serious science background. And it was the very first class that was ever based on just education alone, primarily about education. No flight experience was necessary. And of course, you did have to still pass that physical, which was being run by the Air Force. And so there's a picture of some of the five candidates that were selected for Skylab. Well, moving on forward, there's been 21 more classes. We won't dare go through all of those, obviously. We don't have time for that. But 299 men were chosen, 61 ladies were chosen. Of the 370 that we've had, 212 military, 138 civilians. So they really started taking civilians on, 190 jet pilots, but also almost half a non-pilots. So it's been, and that's by far the biggest class, that picture there from 2009. That was our biggest class. So they've tried to keep a staff of astronauts that was quite large during the shuttle program because, the shuttle, that's 7 positions they needed on every shuttle mission. So that took quite a few. Now the classes are much smaller because, Orion, the spacecraft we're going to fly next week, that's only 4 positions. So we're not, there's 3 or 4 going up to the station each time, and just 4 on these moon missions. So we don't need quite as many. So it has been tapered down. So we will go over section 2 here now on the NASA qualifications, because this is the current, that's a picture of the Turtles, the class in 2020 that we watched the video about. And so watch a quick video on that.
So, you want to be an astronaut? If you have what it takes, we want you up here.
NASA's Professional Astronaut Corps works as a team to train and to fly for the benefit of all humankind and to provide crew perspective for all of human space exploration. We serve our country and our planet by testing, developing, investigating, and flying. Our decisions today ensure mission success and crew safety for some of the most audacious missions humans have ever undertaken, to the moon and beyond. If this sounds like you, then join our team.
Our selection approach is a holistic one. We learn all we can about an applicant in a variety of ways, including resume reviews, reference checks, and for those highly qualified applicants that advance to the interview rounds, we do individual and team exercises and medical assessments. The process involves a lot of subject matter experts, including current astronauts, and takes about 2 years from start to finish. Our goal is to select a class of astronaut candidates that are strong team members and operators, adaptable to a variety of situations, can be positive voices of NASA, and can successfully complete training and ultimately be assigned a mission.
We depend on each other every day. And in space, our lives depend on one another. The success of our missions comes down to the people who are part of them.
Astronauts don't just come from one walk of life or one educational or career path. Their multifaceted experiences have given them a strong sense of purpose, made them adaptable, and exposed them to work with people that are different from them, giving them strong teaming skills.
Make sure your family and friends are on board with your goal. You will need a strong support network because you will lean on them, but don't worry, we'll be here for you also.
Of course, minimum qualifications must be met to ensure an adequate foundation of education and experience. Those details can be found at nasa.gov/astronauts.
So we're going to go over those qualifications. This is the current set of qualifications. If someone came and said, I would like to see what the minimum qualifications are, here they are. U.S. citizen, and now a master's degree in a STEM field. Of course, that's engineering, bioscience, physical science, computers, math, other educational degrees would like geology, things like that would be wrapped into that. 3 years of related experience, so that hasn't changed. And it says if you're a pilot, 1,000 hours of pilot in command and 850 in jets. So, and if you're a medical doctor, time in residency counts towards the 3 years completed by June 25th, Craig. So medical doctors are astronauts. Be able to successfully complete that astronaut physical. So we'll talk about that as we go on. So first question would be, well, what degree should I think of maybe pursuing if I want to be an astronaut? And so here's my advice to young people to pursue a degree in STEM, science, technology, energy, and math. They would be classically aerospace engineering, mechanical, civil, electrical, a doctor of medicine. So you saw Johnny Kim on there on the original video. He's a doctor from the Navy SEALs. So he's quite an accomplished doctor of medicine, but he's an astronaut. Geology, biology, chemistry, math, computer science, wide range of subject matters. Many, many astronauts have had one or another of the degrees, sometimes multiple. So they would ask me, okay, I have an aptitude in a certain area. What college or university should I consider attending? Well, if you have a degree, you can certainly find a list. So this is an example list of aerospace engineering, what I was doing. And so we'd ask inform a young person, well, take an aptitude test, sit down with a person, a guidance counselor, talk to people in the field, like myself or other scientists, maybe a medical physician, seek out an internship even. NASA actually employs at each of its locations up to 500 high school students in internships. And certainly we would encourage young people to seek out an internship or even apply to space camp at Huntsville, Alabama to get experience. So, there's a list of universities that would be considered the best of, and you could, in this particular degree, aerospace engineering, or it could be any other degree, you can find an adequate list like this. Now, you might also ask, well, where did the astronauts go? There's 370 astronauts. Well, where did they go? And when you do that, a surprising result pops up. That if you would look at astronaut schools, you're going to find a lot of those schools are right on this list, but 25% of all astronauts come from the Navy. And it is a surprise. Of course, the Air Force is on here. West Point is on here. Obviously, places like Massachusetts, MIT would be on here, or Caltech is over there on the right. Southern Cal, UCLA, those kind of schools are going to be on this list. This is not a definitive list. I just wanted to show you the types of schools, but it is surprising that school down there on the bottom left, the Naval Academy, shows up right at the top of the list. People ask me, well, why is that? And I'm not sure I have an adequate answer other than the leadership training in the Naval Academy and in the Navy is second to none and fully equips someone to do a space mission. So I would advise anybody, I would like the best chance. I said, at least apply to the Naval Academy or talk to your senator and your representative, see if you can get they'll sponsor you to do that. So anyway, that's what you do what you get if you look at where did those 370 astronauts go to school. Surprising result, in my opinion. Now, let's talk about that physical. The physical looks on the surface to be a no-brainer, 140 over 90 after with intense cardiac evaluation during certification. But it's that second one, the heart recovery rate that just eliminates most people right off the bat. After a treadmill endurance test, you need to have an uptake of oxygen that would match these numbers or better, 40 milliliters per kilogram of body weight per minute. So right away, that's the kind of thing that eliminates myself and a lot of people right there. That is quite a high endurance limit. Then they check for bone density because in space flight, your body is going to change the structure of your bones and your joints. They do change. And so they're looking for high bone density and joint flexibility. So, of course, all of these, NASA has to propose it. So here's the standard, the NASA standard for medical evaluation that is run by NASA physicians. And so we're not going to go through all this, but it is a difficult standard to meet for the medical eval. Now, the astronauts have to pass this every year. So these astronauts that are assigned to the Corps, they have to go through quite a rigorous physical, weekly endurance and workout. So here's the workout.
One of the next things I'd like to talk to you about for physical fitness is aerobic and anaerobic activities. I like to simplify it a little bit for myself, and I just think about balance. And I need to have a balance between activities that involve more long distance, running or biking or things of that nature, and then combine that with on different days or different times where I'll have activities that are shorter duration, maybe a little more intense, or where I'm working harder on my strength activities. And so this is a little bit of a change for where I grew up. When I first started working out, there was a lot of just straight strength training on weights. And then as I was getting ready for football or basketball or track, there was the running piece of it. And now we see a little bit more of a combination of those activities where even as I'm lifting weights, I can put in some anaerobic and aerobic type activities. So I can do lighter weights and I can be pushing for longer time frames, or I can do some heavier weights and get more of that anaerobic push. Or it doesn't even need to involve weights. There's a lot of activities you can do in your house that don't require any weights whatsoever. You can do burpees, you can do push-ups, sit-ups, things of that nature, where you're going to get some of the same benefits, anaerobic benefits that we've talked about. And then you can go out for a nice run, or you can get on your bike and get some of that aerobic fitness in there. So again, for me, it's a balance. You'll see as you look at my workouts, there's going to be pieces of both of those mixed throughout the day, throughout the week as I execute my fitness program.
Okay, so that gives you a little insight into how in shape. I got to admit, I've never seen an overweight astronaut. So these guys do keep themselves in incredible shape. Now, if you are selected, you're going to go to what they call ASCAM training for 2 years at Space Center Houston. So down in Texas, we have a training facility. So here's a quick video about the training facility.
Building 9, where we have a whole one-to-one life-size mock-up of the International Space Station.
Take me back to when you were first selected to be a part of NASA. What did that feel like when you got the acceptance letter?
It's actually a phone call, and I was just so much in shock that I said something very eloquent like, really? We're going to be welcoming the new class of astronauts. They will embark on this 2-year astronaut candidate training period where they will be instructed and trained and then demonstrate proficiency in 5 main areas in order to graduate from being astronaut candidates to become full-fledged assignable astronauts. We have everyone's favorite, I think, learning how to use the spacesuit. We do that in the neutral buoyancy lab. You're weighing over 400 pounds when you're in the suit. So every movement, every hand movement is like squeezing an exercise ball. Then we have robotics training. So we learn how to fly the Canadarm, the big robotic arm that's on the outside of the space station. So we still use it on a routine basis to either reconfigure the space station, using it for spacewalks, using it to do different tasks or repairs on the outside of the space station. Third area that we have is the International Space Station systems. When we're up there, you know, if a light bulb needs to be changed or the toilet breaks, and that does happen quite a lot, we can't call a plumber or an electrician. We have to have a really diverse set of training so that we do that, all of that ourselves. So the fourth main area is Russian language. It's an international crew up there. Everybody has to be able to speak both Russian and English. And then the fifth main area in which we have to become proficient in order to graduate is flight training.
So this is Ellington Airfield, and this is where we have our T-38s, and we do something called space flight readiness training. It is the most real world thing that we do other than the actual flying in space. And so it also requires us to learn to prioritize, make decisions, and communicate effectively. And so it's a really dense type of training that we get to do.
I mean, yes, it seems very important, but it also seems really fun. I mean, dangerous, but fun.
Dangerous, but fun. That's a good description of flying the T-38.
Okay, so going over this quickly, the 5 main areas. Here's a picture of the International Space Station in Building 9 there, where they have the entire station mocked up for the astronauts, and they'll go through 2 years of training on all the systems of the space station so that they can repair or augment any of the systems and that they would need to do while they spend their 6 months up there. Of course, that spacesuit training, they love the pool, the neutral buoyancy pool, and working with the spacesuit. And that's basically simulating a spacewalk. But when we get to the video, you'll see what else they're doing, which is interesting. Flying that robotic arm is not trivial. That's a huge piece of equipment out there. And you might have to grab a satellite, or usually it's grabbing the supply truck, the spacecraft they send out to resupply. And they all hate learning Russian, but they have to do it because they might have to fly a Soyuz capsule to come home. And you can't do that without knowing Russian. So right now, there's a Russian cosmonaut in charge of the space station. So they're all up there speaking Russian today. And of course, the T-38 flying that you just saw in the video. Here's the neutral buoyancy lab.
Take your breath away. Here's the pool.
So this place is really cool. It's really big. There's a giant pool here. So can you tell us where we are?
We're at the Neutral Buoyancy Lab at the Sonny Carter Training Facility. So it's actually 202 feet long, 102 feet wide, 40 feet deep, and 6.2 million gallons.
Wow, that's a lot of water.
Neutral buoyancy can simulate the zero G, the zero gravity that astronauts feel in space better than any other environment here on Earth.
So what's like a typical day for a diver, like yourself?
A typical day for a diver is supporting ISS operations.
So what is the ISS mock-up for?
It's for spacewalk training. So all of the mock-ups are exactly the same size and shape, with the handrails in the same locations as the astronauts would expect to find in space. It's important for them to practice here in the pool so they know what to expect when they get to space. On the dive team, we have safety divers, float camera divers, and utility divers. The safety divers work as a pair of 2 for 1 astronaut.
So what's happening today? There's so much activity going on.
Yeah, I told you it was going to get crazy. We have an astronaut getting suited up in a prototype version of the XEMU, which is the exploration suit intended to walk on the surface of the moon.
What's the difference between this suit and the suits that you normally use?
There's better mobility. So that includes walking with your feet. That includes reaches with your arm, as well as field of vision. So the helmet bubble is a lot different on this suit. So the astronaut can see more peripherally.
Okay. Cool. That's a fun fact. I did not know that. Oh, I see a lift. Here he goes. Here he goes. Goodbye. Have fun on your test today.
Wait, you forgot your mask.
How do you recreate the moon down there?
It took a lot of iterations of different types of sand to find the perfect hydrophobic magic sand. They can trench through it. They can take sand samples as they would.
Can build sandcastles. Oh yeah, we do that a lot. That's fun. So I see you're all suited up. Can I jump in too? No. Okay.
All right, so that's the nutrient-buoyancy lab. Everybody loves to train in that lab. As you can see, they've actually simulated the moon on the bottom of the pool. So they had to find a special sand that wouldn't completely make the pool dirty. So they simulated this so we could test all the new suits they're going to use. They talk about the robotic arm and how tricky it is to run such a large, it extends over 200 feet. It can hold over 200,000 pounds in its hands as it latches onto objects and moves things around the space station. So it is tricky to run. And they spend quite a bit of time training on the simulator. And it's mostly because of this. At the end of the arm, you might have an astronaut. And so you have to be super careful and make sure that you put him in the right spot for him to grab on or to make repairs. They've gone as far as all the way out to the end of the solar panels on the space station to effect the repairs because we've had items, micrometeorite, space junk, hit the space station in the solar panels and knock out a section. So they'll send someone out there to repair it on the Canada space arm. So quite an interesting assignment to be out there on the end of the arm. We talked about the T-38s. It's pretty straightforward. They create real-world space simulations in the cockpit where systems fail, and you have to work together as a team to figure out various things that happen. And it's actually not that easy. They've lost a couple astronauts early on in the program in '66. Doing a simulation. So they're a lot more careful when they do their simulations now. But this is, as Victor Glover said in the video, this is the real world where you're flying a craft and you have to work together as a team to solve a problem. So that's what T-38 training is really all about. Now, here is the secret sauce. How do you select astronauts for a mission? And there is the launch of Artemis 1 on the right, and we're getting ready for the 4-man crew of Artemis 2. And the question is, how did they get selected? So it is a mysterious process. No one really advertises this, but this is how it happens. The criteria is set right at the beginning of the mission when it is first announced, and it remains pretty secretive. The decision of who will be the next person to step on the moon is going to be a tightly held secret. But it'll be these three people that make the decision. So that first person is the chief astronaut. And right now, the chief astronaut is Drew Festel. And if he does not fly Artemis 3, he would be in the running to be on Artemis 4, which will be the first moon landing we've had in 50-some years. The second person, Drew will select 8 people for the 4-man mission. The second person that will overlook it is the chief of flight operations. Currently it's Norm Knight. He's in Houston, and he will make the decision as to who of the 8 would be preferred for the 4 spots. And so it'll be the 4 plus 2 alternates. So out of the 8, it'll be 6 that are selected. And then it gets bumped up to Vanessa Wyke, who is the head of the Johnson Space Center. And she gets to make the call on who the 4 will be. They'll be recommended, of course, by the first 2 people, but that is the process for selecting the missions. And we don't find out who's selected until they decide that they're happy with the selection. So here is the 8 that was selected for this mission, Artemis 2. And the chief astronaut was Reed Wiseman, the guy in the bottom right, and he selected himself. So that can happen. And if he's qualified, no problem. So he has to resign from being the head astronaut, and now he's going on this mission. So the 4 people who are going to fly this mission were selected from these 8, and then 2 alternates. So here are the 4, Reed himself, Victor Glover, who's the most experienced pilot of the bunch, Jeremy Hansen, a Canadian pilot, one of our Canadian astronauts, and Christina Cook, who is the most experienced female astronaut that we currently have. So that's how we got to these 4 through that process. And there will be another selection process when we come to Artemis 3 and then Artemis 4, which is currently scheduled to be the moon landing in 28. That will be the really interesting selection process. We all are taking bets on to who's going to be selected. Now, if you can't be an astronaut, you might want to be like myself. We're support personnel, and the question always comes up, well, how many of those does it take to support an astronaut? Good question. So the people of NASA are professionals united by a common purpose. Here are a couple of pictures, and that happens to be JPL, where I work. The photo on the left is the Space Flight Center, where we controlled the landing of the rovers, and the crew on the right, that is the design and build team for the rovers. And these are interesting times because it's all new science. So yeah, working for NASA, you might expect to be put on a mission that is completely new and different. And that's the exciting part about it. And that's why I went out there. I wanted to do something new and different. It also happens to be always named as the best place to work for the federal government. So this isn't the IRS. This is a lot of fun if you're an engineer or scientist. And it is a great place to work. As you know, they're everywhere. So here is all of the locations, all the major ones. And starting from New York City, which is Goddard, has its Spaceflight Study Institute in New York City. And going down south, there's Wallops Island. If you want to watch a launch, that's the easiest place to go from Rochester to see one, going down to Wallops. That's in Virginia. Langley, right outside of DC, that's where they did the first research in NASA's early days, before it was even NASA. They had the wind tunnels there at Langley. Out in Ohio is Glenn, and that used to be called Lewis. So that's a big research facility in Ohio, Cleveland, Ohio. And then there is, of course, Marshall. That's called Rocket Town. That's where we built NASA built all the big rockets, including the new ones. They're built at Marshall Space Flight Center in Huntsville. Of course, Kennedy, where we do the launching. And then, of course, Johnson over in Texas, and White Sands, where all the testing is done on the rockets, ground testing. JPL out on the West Coast, where I work, a lot of interesting new technologies, including the rovers. They're done there. And up there in San Francisco, Ames. So the Ames Research Center in San Francisco. So places all over the country where you can get involved with the 17,000 employees of NASA. These are some of the people that will reshape our world for years to come, decades to come even. Here are some of the originals from the 50s. We call them the people who changed the world because they invented the space culture that we currently have. And many of them, over 25% of them, were ladies because there was no discrimination. NASA needed the best, the smartest, the most highest aptitude they could find. And so you're going to find people behind the scenes of every flavor, every color, every origin. Of course, mostly American citizens, but they were looking for the best and the brightest. And a lot of the ladies became what we called computers. And that was actually a job title, computer. And they were doing the orbital calculations. Of course, upper right, that's Katherine Johnson, who you probably remember from the movie, The Hidden Figures. She was doing those calculations with a slide rule on paper for John Glenn. And John, said, well, if it's okay with Katherine, I'm ready to go and, light this rocket. So these people were very, very, very influential early on in the space program. So we do have 41 astronauts currently on the roster and the 17,000 employees. So the answer to that question is it takes over 400 people to support every astronaut. And someday, hopefully soon, NASA is going to be hiring again. We actually just went through a big workforce reduction post-COVID, and over 2,000 people retired in the last year. They're going to be hiring again, and you might get a chance to do this on the right. That's our team from Rochester working on the James Webb Space Telescope in Houston. So And that is what I did. I worked on their telescopes, and I wasn't down there, but knew a lot of the guys down there, and it was exciting times for us in Rochester to be involved in the NASA program. So here is a NASA astronaut, Jasmine Mabelli. She's actually one of my, I think she's one of the candidates to go on that first moon mission.
Hi, I'm Jasmine McBelly. I'm a NASA astronaut, and this is Ask NASA. NASA will be opening its applications for more astronauts on March 2nd through 31st. So we've got a bunch of questions related to that. What is this online assessment about? It's testing things like your aptitude and skills to make sure earlier in the process that you have what it takes to be a NASA astronaut. Okay, let's move on to our next question. What degrees don't count? So I like to be positive and start with what degrees do count. So you do need a master's degree. Thanks. You need a master's degree in a STEM field, so science, technology, engineering, or mathematics. There are certain degrees in there that don't count, such as nursing, psychology, exercise physiology, or social sciences. But for details on that, you can go to nasa.gov/astronauts. What was the weirdest question you got during your interview? So when I went to see the ear doc during the interview, he asked me if I could do a Valsalva maneuver. You may be familiar with that from flying in commercial aircraft. Anyway, afterwards, he told me I did a textbook Valsalva. Shoo-in. Next question. What are you most excited about for being a part of the Artemis generation? Wow, I could go on about that one for a while. First off, we haven't stepped on another planetary body in my lifetime, so it'll be super exciting to see someone I know stepping on the surface of the moon, but also how that sets us up for future missions to go farther than we've ever gone in our solar system before onto Mars. So we're constantly working on training. Our first 2 years were purely training. Tomorrow I'm getting in the neutral buoyancy lab to practice the spacewalk. Friday I'm getting in T-38. So it's a continuous process every day.
Okay, so that's Jazz McBelly. She's actually on my list as being one of the candidates that I think is probably a shoe-in to go to the moon eventually. She's the most experienced helicopter pilot they have out of the 40 astronauts. She has thousands of hours from the Marine Corps flying in helicopters. So that is actually what the astronauts are training on, the moon astronauts. They're training in helicopters to learn how to land on the moon. And so that's kind of what I think bumps her up to the top of the list. So Craig, that's kind of the end of the presentation. If you want to open it up for questions, or if there were questions in the chat that someone wanted to ask.
I did not see any in the chat. Everybody wants you to unmute yourselves and turn on your video if you want. And if there are any questions, Jim can answer them.
You guys have any questions?
You want to stop screen share?
Yeah, I can stop and see if I can see the chat. Okay, sure. We have a question in the room.
When you pick a crew, how do you get a Russian into that crew?
So, yeah, that's a great question. What about that Canadian, and what happens if someone's from overseas? They actually have to come here. They have to know English, and they have to participate in the 2 or 3 years of specific mission training for that flight. So that person from Russia, they will speak English, and they'll come here and be part of the training for the mission. Same thing if we were going to send someone to Russia.
Okay.
Same exact thing.
That makes sense. I just didn't know if there was a quota set by the politicians.
No, the politicians, thankfully, don't have a lot to say about the program anymore. Mm-hmm. Yeah.
There's a question in the chat. Do you know anyone in the astronaut program who was a programmer?
A computer programmer?
I would
That's
assume.
that's a good question. Many of them have programming background. I don't know anyone specifically. Maybe I should go through and look at the astronaut corps and see that of the 8 that were chosen for Artemis, they were all system engineers. So one of the degrees they got is system engineering, and they need it because the whole thing is about systems, space flight systems. Now, yes, the Russian training is similar, nowhere near as in depth. It takes about 6 months to get ready to go to the space station from the Russian launch vehicle. So since they've stopped that, we haven't really had anyone going up on a Soyuz in the last few years. So most of them are training on Dragon. So they're training at NASA, and then they're going out to Texas and training on Dragon, the spacecraft simulator out there, and then coming back and launching. Now, was there an astronaut from RIT? Well, that's a good question. I don't know. Does anybody online know the answer to that? I should probably look that up. Yeah, I'm not sure. I'll try to find that out. We should know that we certainly do have astronauts from Rochester. In fact, one of our most, I think Pam was up at least 3 times. She was from Honeycomb Falls, graduated from Honeycomb Falls High School, went to college with some people I know, and moved on and joined NASA, got be part of the astronaut corps. So certainly people from Rochester have been part of NASA. Yeah, Pam Melroy. I'm sorry, I didn't say her last name. Pam Melroy. She was the assistant director. I'm not sure where she is now. But as far as RIT, we're going to have to look that up. Yeah, that doesn't surprise me that people have run into Pam. She does sometimes come back to Rochester, and you'll see her speaking at the Science Center or at an alumni association in town. What school did she go to again? Remember, I spoke at the alumni. It's one of the ladies' colleges. I've forgotten which one now, but that's where I read into her. What's that? Wellesley. That's it. Wellesley College, where Pam went. Interesting.
Is there a time when it's too late to switch careers and try to become an astronaut?
Yeah, unfortunately, I was thinking of doing it, but I would have to go back to school. And that was in 1983, 84 when they were recruiting. Once you turn 36, it's sort of too late. And yes, the whole thing about not having a NASA administrator threw us back about 6 months. So Isaacman has made drastic changes since he's been appointed, because we were waiting on all these decisions that would come down about, what is the moon program going to look like, and what should we fund, and what direction do we want to go? So he has kind of retooled it very recently, in fact, and even last week there were decisions coming down, and now they have a new Mars mission, a new Mars rover coming on, and they have a new moon lander competition that's going on right now. So, Jared Isaacman has been making quite a few decisions that have been lacking over the last 4 years since we've had this transition in leadership.
I read somewhere that the moon is less of a primary objective now than an intermediate objective on the way to Mars. Is that a fair statement?
It kind of bounces back and forth. It was primary when they were using it as a stepping stone, and the objective was to learn how to survive in a deep space environment, outside the radiation belts of the Earth. And that we're going to learn that pretty quickly in the next 3 missions, how can we protect astronauts for long enough to get all the way out to Mars? And can we then land on Mars and find a place that's, better suited, where we don't need so much radiation protection. So, yeah, it kind of bounces back and forth. And right now they are in the mode where they'd like to do a minimal amount of work on the moon and target getting out into the solar system faster. So I think it has kind of swung that direction.
Mm-hmm.
So which company will be selected? So there's a hot competition, and Elon Musk was very embarrassed about the fact that SpaceX was way behind. So SpaceX was initially selected, but their offering kind of fell flat. And Super Heavy, which is that big launcher they've been using, they've been targeting that and less on the lander because they felt like they had that technology kind of nailed down. But Blue Origin has come up with a really cool new design, and they want both of them to go what we call to the preliminary design phase, or PDR, so that we can assess these both of these designs and figure out which one we feel is the safest, best design for landing on the moon. I wouldn't be surprised if both of them were built, though. That is the way they tend to do things now. And both of them will be built and tested, but they need to come up with something quickly. So they are going ahead, funded by the companies to build these. So it will be interesting to see how that goes. I wouldn't count out SpaceX. They certainly can land it, and so I wouldn't count them out. But that's a great ongoing question. So for the first time, we're going to meet the lander at the moon. So the lander will be out there, circling the moon, and we'll meet the lander out there. So yes, refueling is still in the offering. They still need to do some refueling if they want to take a heavy lift. And for the initial missions, it'll be less. They're only going to take a lander out there and the Orion spacecraft itself to do the first landing, but they're going to need to refuel to get the heavy equipment out there. Like if they're going to take a moon base or a moon rover, they're going to need to do some more refueling. So they have tested the refueling with the same, during the SpaceX, Starliner testing. They've been doing refueling tank to tank. So they're going to need to do a much more extensive refueling test where we have two vehicles involved in the refueling. So before they're ever going to do it with a manned mission.
Any other questions? Well, Jim, that was a great talk. Thank you very much for your time
thanks, guys.
expertise and taking time out of your vacation as well. That was
no problem there.
Meaningful to us.
Enjoyed it.
Yeah, we're happy with your association with us.
Yeah, we'll see you next time then.
All right. See everybody next month. And is Adrian still on? Adrian, do you want to say anything? Adrian's actually giving the introduction to quantum mechanics talk. Do you want to say anything about that, Adrian?
So, yeah, everything's ready to go. So we'll be talking about trying to do some sort of level of introduction into quantum mechanics. Good. It's a pretty large, complex issue, but we'll do the best we can in an hour.
Tremendous.
You'll enjoy
thank
it.
You very much. Thank you very much. We're looking forward to that. And Jim, thank you again.
Okay, appreciate it, Craig. We'll catch you next time.
Good night, everybody.
Good night.
Good night.